Hi everyone. Today I want to talk about dividing complex numbers. It's complex. That's not funny. In order to divide complex numbers, we need to know something extremely important, and that is the complex conjugate. I know. The complex conjugate is a multiplier, but it's kind of like a process too. Let's get there. It's a process that multiplies the denominator by either that same exact term, but with the opposite sign, or that same exact expression, but the opposite sign that links those two things together. See, when we divide complex numbers, it's kind of like when we divided radicals or radical expressions. We can't ever leave a radical in the denominator. Same exact thing with imaginary or complex numbers. We're not allowed to leave them in the denominator. It doesn't work that way. So we have to do something with multiplication. Multiply by the complex conjugate. Now, again, there's reasons for this. The first one is we just simply can't leave I in the denominator. It's one of those math rules that someone made hundreds of years ago. Number two, if we didn't multiply by the opposite sign, we would end up with actually more imaginary numbers or more complex numbers. We don't want that. More is bad here. We want less. And more importantly, we want less in the denominator, as in none. I know. So the best way to teach dividing complex numbers is to do it. So let's take example 1. Here we have 5 divided by negative 5i. It wouldn't be much of a video if I could just take the 5s out. Can't do it like that. So 5 divided by negative 5i. Well, I'm going to multiply by the complex conjugate. In this particular case, the complex conjugate is going to be positive 5i. So I'm going to create a new fraction with 5i on the bottom and 5i on the top. Now I'm going to multiply across, numerator times numerator, denominator times denominator. 5 times 5i is 25i. Negative 5i times 5i is negative 25i squared. But remember from a previous video, I squared is actually negative 1. So what we have here is 25i over negative 25 times negative 1. Again, we're going to simplify, and the denominator is going to be 25. Now, we're not exactly done yet, because this expression is really, really nicely simplifiable. I can just take the 25s out, and I'm going to be left with I. So, in this particular problem, 5 divided by negative 5i, my answer is I. Let's move on to another problem. Here, 1 divided by negative 2i. Okay, well, what's the complex conjugate? 2i. Good. So let's do that. We're going to multiply on both top and bottom by positive 2i. We're going to multiply across, which gives us 2i over negative 4i squared. And yeah, I'm going the long way, but I need you to see the progression of how I kind of evolves over time. This is going to be 2i over negative 4 times negative 1, which is going to give me a 2i over 4. Simplifying the 2 and the 4, that's going to give me I over 2. Final answer. Now, we've got one more problem that looks similar to this. Why don't you go ahead and pause me and see if you can figure it out. Okay, you've paused me. And I moved, so you know that you were paused, because I was over there. Now I'm here. Teleportation works nicely that way. Negative 2 over I. Let's do it. If I is a denominator, the complex conjugate is negative I. So I'm going to make a new fraction, multiply by negative I on top and bottom. That's going to give me 2i in the numerator. The denominator is going to be I times negative I, or negative I squared. This one's a little tricky. Negative 1 times I squared is negative 1 times negative 1. This is going to give me 2i over 1. So my answer is just 2i. And I'm running out of space. The pink marker is not so great. It doesn't blend well with my forehead. Let's move on to something else. Now, if you're thinking to yourself from those previous 3 problems, why did I have to multiply by the different sign? I could have easily gotten rid of I by just multiplying by exactly what the denominator was. Well, the reason is because it's unfair if the rule works one way, but it doesn't work another. So we just kept the rule for both. This is really what the complex conjugate was built for, when we have multiple terms or a binomial in the denominator. So we're going to do the same process. The question really is here, what is the complex conjugate of this expression? Well, remember, it's exactly that expression, but the operation that links them together is going to switch. So our multiplier, our complex conjugate, is going to be -4 minus 2i. So we're going to multiply both the top and bottom by -4 minus 2i. -4 minus 2i. So we're going to distribute the 9i to both terms on top. So 9i times -4 is 36 negative I. 9i times -2i is going to give me -18i squared. We'll get back to that one in a second. But let's go ahead and simplify the denominator. This is going to be where we are multiplying binomials. Area model works fine here. But what's going to happen is, and you're going to find this out really shortly, is that takes a long time to do. So here's the shortcut version. Because what's happening, the middle terms will cancel. That's the reality of using our complex conjugate. It cancels the middle terms. And I'll show you this on another problem. So what we're really doing here is we're multiplying the first term times the first term. -4 times -4. That's 16. And then what we're going to do is we're just going to multiply positive 2i times -2i. And positive 2i times -2i is -4i squared. Now we can get rid of both of those really ugly I squareds. So the top is going to turn out to be -36i minus 18 times -1, or just plus 18. So what really happens here is this sign just changes because that becomes a -1. So a negative times a negative gives me a positive. Right? Now the denominator is going to still be that 16. Same process as the numerator. That I squared is going to turn to a -1 and multiply times the -4. That's going to become a 4 positive. So now I can combine things and clean this up. This is going to end up being -36i plus 18 over 20. We're almost there. All three of these terms have something in common that I can divide out. And that's going to be a 2. See, the one last thing about dividing complex numbers, much like we did with dividing radicals in Algebra 1, is all three numbers or all three terms need to have something in common to simplify. We can't pick and choose. So for example, let's say that 18 was a 17. I wouldn't be able to simplify anything. All three terms need to be simplifiable, or they're not at all. So if I divide 2 out of all three of these terms, I'm going to get -18i plus 9 over 10. And that's actually my final answer. Now you might be saying to yourself, what happened to the a plus bi form? Remember, that's the form we want to keep things in? Well, that kind of goes out the window when we have a denominator. So this actually is a very appropriate answer. If you switched it and made it 9 minus 18i over 10, that works too. Let's try another one. Here, example 5 is 2 divided by 7 minus 5i. Now I'm going to work this one out the long way so you can see why we use the complex conjugate. The complex conjugate of this term is 7 plus 5i. So what I'm going to do is I'm going to multiply by 7 plus 5i on top and on bottom. Again, I'm distributing that 2 to that 7 plus 5i. If you wanted to put parentheses around the top, that works too. So this is going to be 14 plus 10i. Probably a lot easier than the first one. I should have had this one first. That's okay. Now, when we multiply binomials, again, the area model works. So for instances like this, I'm going to show you the area model. You certainly are welcome to use it if it makes more sense to you. So I'm going to make my area model squares up here. And let's plug in the things we know. 7 and a -5i, and then 7 and a plus 5i, right? Because I'm using the second binomial. And let's fill in our squares. 7 times 7 is 49. 7 times -5i is -35i. 5i times 7 is 35i. Do you see what's going to happen here? 5i times -5i is -25i squared, or -25 times -1, which is just 25. So I'm going to circle that because that's going to be our final answer for that portion. Now I'm going to combine like terms. Well, this just becomes 49 plus 25 because positive 35 and I and negative 35i cancel out. So 49 and 25 is 74. So this ends up being 74 on the bottom. 74 is the denominator here. Again, take a look at what we have. I've got terms that I can divide something out of. They all have a 2 in common. So I'm going to divide by 2 on all 3 terms. 7 plus 5i over 37. Now that looks a little different than our first problem's answer because we did have this switched. Again, when we have a denominator, when there's a fractional or a rational thing here, it doesn't matter how a plus bi works as long as it works. Can't simplify anymore, final answer. Now, I'm going to leave that problem up the way I worked it out. Take a try at example 6, right? I won't say anything as I do this problem, but you can see my thinking as I go, and I'll go a little slower. But I want you to try it, because this stuff sucks. I know you can hear that, I'm sorry. Final answer. Now again, I worked that process out, but one thing I do want to say is it actually possible that writing slower makes my handwriting worse? Take a look at what's going on here. That's a mess. At least here, we're efficient, we're making things happen. This is hideous. Ugh. 4 minus 36i over 41, if you got that, you're looking good. Let's finish up. Okay, so things to remember about this video. Number 1, we've got to use complex conjugates in order to divide complex numbers accurately, correctly. Number 2, I can't see it because the camera's in the way. The complex conjugate is the opposite sign. So basically, think of it like this. Whatever's in the denominator, we're multiplying it again, right? We're going to create a new fraction with that denominator on both top and bottom, but we're just changing the sign. So if it's a 1-term deal, just make it the opposite sign. If it's a binomial or 2 terms in the expression, just change the sign that links them together. Don't change the negative in the front of a number though. Just change the sign that links them together, the operation. And then number 3, the reason we do this with the complex conjugate is to make less i's or make less complex numbers. If we multiply by the exact same thing, we'd make more of things. That's not good. See you next time.